Hey robot makers, how you doing? Hope you're having a good day so far. So today's show, do you want to know how to control a quad robot, a SMARS Quad robot, with a microbit and using Microsoft MakeCode to bring it to life? So that's what today's show is all about. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to the keynote. Here we go. So the session goals for today is to learn how to use the microbit with the SMARS Quad and MakeCode, which is a Microsoft product. So we want to add the microbit to the SMARS Quad. I've created a holder board for that. We want to connect it to the PCA 9685 board using I2C or I2C, and create some movement code in MakeCode as well, using either Python blocks or JavaScript. We can use any of those things. I would say this is actually an intermediate, beginner to intermediate, because there is some connectivity involved, but it's probably more skewed towards the beginner, if I'm honest. So let me, without further ado, get over to just the overhead, just to give you a quick idea of what. So this is a SMARS Quad robot. So you can see it's got 4 legs there. It's got a little microbit there, and I've created a little holder for that to sit in. And I've just got a 9-volt battery that's powering the servos, and there is a little LiPo battery just underneath there that I can plug in. If I just plug that into there, you can see it's flashing some lights. If I press that, it'll just run a bit of test code there. So I'm just going to turn that off for now. So that's what we're shooting for, and we're going to be controlling that with MakeCode. So let me tell you a little story first, though. So I thought, adding a microbit, to the quad, this is going to be a piece of cake. I've done all kinds of, Pico SMARS. I've done adding Arduinos, ESPs, ESP32s, 826, whatever it is, 8266. All these kinds of things. And I probably spent about half the week trying to mess about with I2C, reading really low-level documentation on how to pass bits across the I2C bus, all that kind of stuff, baud rates, how it all works internally, packing byte arrays, all manner of stuff. I thought this was really straightforward and easy to do. And then I realised, MakeCode is designed for education, so this has got to be easy. How easy could it be? Am I doing something wrong here? So it is easy. It turns out I just googled a few things, and there was an extension that somebody had already written to make servos work, and they did all the hard work for me. So things don't actually have to be that hard if you just do your research properly, which I did do. I dove straight into the how do we make this work? This must be complicated, and it really wasn't. Now the cool thing with the microbit is it already comes with loads of sensors and lights and sounds and things like that, so you can really make the SMARS Quad into a fun experiment. I'm going to say toy, that's the wrong phrase, into a fun kind of experiment and learning platform. So the first thing you'll need is an edge connector, something to break out the microbit. So let me just show you this for a second. So I've got a standard microbit. This is one of the version 1 microbits. And you can see there it's got these connectors along the bottom. The idea is you get, let me just grab some wires there. You get some of these crocodile clips, and the correct way is you're supposed to pinch it into the hole like that. If I can just show you that there. So that's connected there, and you might connect, I don't know, some voltage to, you just grab that, to the 3-volt input there. These are not easy to handle. And the black one to the ground, like so. Well, that's great if you only need to have 3 inputs, not 1 and 2, and the other 2 are for sort of powering it. But what about all these really small ones in between? So in between you've got these tiny little notches, and they're actually pins as well. So what we need is some kind of breakout board. And there's quite a few companies that do these. Non-surprisingly, Adafruit, they do some. So they have one that's called the Crickit. So I'll just show you that. So that's the Adafruit Crickit. This is great, but it's pretty huge. It doesn't sit very well on top of or inside of the SMARS Quad. And the idea there is you put your BBC microbit sort of in there, and you can see little LEDs. So it's sat, but that's exposing all those different connectors and things to these things around the edge. So you've got motor driver connectors, you've got servo connectors there, and some other signal I/O pins. That's fine. It's a bit bigger than our SMARS Quad, so not ideal. next one is a Kitronics one. So Kitronics do quite a lot of stuff for the microbit. And as you can see there, this is a motor shield. So they've got sort of motors out. They've got quite a few motors out, and you just place this, I think, that way round so that it exposes all their edge connectors, but specifically to do jobs. So you can't connect anything directly unless you solder some header pins across that top bit there. Now the one that I've actually plugged in, I'll just show you the third one I've got here as well. So this is one from MakeCode, sorry, from MonkMakes. It's all the make things. And Simon Monk creates these. So if I just put that in there, is that the way around? That's the right way around. And this one is great because it exposes the I squared C. It's actually on that side there, them 4 little pins. So it says I to C, and you've got your SDA, your clock, your data, your clock, your ground, and your 3 volts. So that's very straightforward. I could have used this one, but I decided to use another Kitronics one just because it was really compact and small. And what I then did was create a 3D printed holder board, which I'll show you a bit later on, but a 3D printer holder board so that they can sit into the SMARS robot, and the little board can go on there and just keep it all in one place. So we needed some kind of edge connector, and that enables us to connect pins to the PCA9685 board that controls the servos. And we also need to power the servo separately than the microbit. And the microbit you can control, there is a little white jumper thing there. That's a JST connector, and you can power it, which is what I've done there. I've just got a standard LiPo battery, and that came with, just so happens, the right JST connector to connect it up. Adam says, hey there. Hey Adam. Okay, so let me just go to the next slide. So the Kitronics holder, what I did then, you can just about see it there, I 3D printed the little board, and that just allows it to sit in place. And if you want to print your own version of that, somebody's actually already printed this out. I literally uploaded it at lunchtime today, so somebody already grabbed hold of that. So there's a link there, and the link in the description and the YouTube description to that Thingiverse thing. So if you want to grab that and print your own out, it doesn't take long to do. It's probably about an hour, 2 hours, depending on what your settings are. I printed one in very high quality and got the measurements ever so slightly out and redid it, and then I printed another one in really low quality, and that came out fine as well. So you can do them quite basic shape. There's no intricate stuff there. So microbit pinouts. So it's useful to understand what the pinouts are on the microbit. This is a bit of a small zoomed in thing. I can actually go a bit larger, I think, on that maybe. Not great. I'll just stay there. I've got another slide in a second that kind of zooms into that. We're only really interested in pins 20 and 19 for the SDA and the SCL, which is our data and our clock. And together they form the I squared C bus. And they're right next to this ground thing here. So you can see these blue areas. So if I just go to the next slide, you can see a little bit more zoomed in. So what we're actually going to be doing there is plug in pin 22, or any of the ground pins, there's quite a few of them there, I think there's about 3 of them, into the ground of the PCA9685 board. Then pin 20, which is, it's actually the 21st pin, just to confuse things, but it's known as GP, general purpose pin 20. That's going to go into the clock, and pin 19 is going to go into the data. And then we put our 3.3 out from the microbit into the VCC, not the V+, you'll blow everything up if you do that, the VCC. And we do need to power the PCA9685 board separately from the microbit. You can actually use the same battery if you've got kind of a double-headed thing. It just shouldn't go through the microbit, because you kind of draw all that power through these very delicate pins and circuitry. So you just need the raw power to go into this. I've actually just got a separate 9-volt battery going directly into that, and that works fine. So if you like these kinds of videos, please remember to like, comment and subscribe. You can like this particular video now if you're watching live. You can like the video afterwards if you like this. If you don't, give it a thumbs down, or don't give it anything, but give me a comment. Let me know what you think about this. Let me know if you find this kind of video content useful. And we'll come back to the other stuff slightly later on. Okay, so what we need to do is configure each limb, each leg and foot of our SMARS Quad. And I went through these when we did the... Was it the how to make the SMARS robot walk in a Python video quite a long time ago. That was before I was in this this new studio. But the information is still the same. We just need to use the microbit instead of the Raspberry Pi Zero. So we've got a couple of legs and we've got a couple of feet. So when I talk about a leg and a feet, what I mean there is this limb here that connects directly to the body. I'm calling that the leg. And then this one here is the foot. So this one that goes up and down here is the foot. This one here that goes side to side is the leg. So there's 4 legs and 4 feet. And the way that I refer to them is it the front left leg, the front right leg, the back left leg, and the back right leg? And then the same with the feet. So the front left foot, the front right foot, back left foot, back right foot. Now they all have different angles and different orientations as well. So if we think about a regular servo, I'll just think to see if I had one to spare. Or what I can do is just grab one of these quads that I've got just in the back here. So just for a second, just to understand this. So we've got a servo in here. And this servo, this one is kind of in this orientation. So the little servo horn is pointing straight up, and that allows it to rotate from that orientation to that orientation. So it's not actually going more than about 90 degrees there. If we got that to go the other direction, it would actually clash with this and try and pull itself out of its socket, which is not great. So what we need to do is set a minimum and maximum range for each of the servos. Now, when I was talking about the orientation, like I said, this one is in this kind of orientation. The one that's directly opposite is it looks the same orientation, but the actual movement of the limb is going from a different range. So if that's going from, say, 0 to 90, this one is going from 90 to 180. And that's to do with the orientation. So depending on which limb we're talking about, whether it's the foot, whether it's the leg, which side it's on, we need to understand which orientation these things are all in. So that's what this slide is all about. So as you look at it top down with these kind of this kind of 4 connector things facing upwards. So that's as we look at it, the robot like that with its circuitry there. So that's the front, that is going to be the left, and that is going to be the right. So that's the left, that's the right, that's the front, that's the back. So what we have here is the minimum and maximum angles for each of them. So like I said, they can go from about 9 degrees to 90 degrees for the front left leg. And then, yes, it's very odd. The camera's reversed. Adam was just saying kinematic confusion. There's nothing quite like it. This is why you need to draw these things out and print them out. So it's either between 9 and 90 or 90 and 180 degrees, depending on which orientation the servo is actually in. And when they are on the feet as well, that's similar, that they're pointing in different orientations as well. And that's what I mean by, is it inverted? So is the servo actually the opposite of the other one on the other side? Is it kind of a mirror? And if it is, we need to just take note of that, because we can run the same code, but just say if it's inverted or not, just run a different piece of code. And then the channel is where we have our PCA 9685 board. We have 16 different channels that we can plug them into, conveniently labeled 0 to 15 because computers count 0 as a number, but whatever channel they're on, we need to remember that. So I've come up with a channel sequencing thing for the feet, and that's what this is here. So 0, 6, 2 and 4 is the orientation that I've picked for those front left, front right, back left and back right legs. So next up is the feet. So similar, the feet have a maximum and minimum orientation. So again, if I just grab this one here and I show you on this limb here, so this can go from about 150 degrees down to about 50 degrees, and that's where it starts to clash with its own body. So that's why that's the range of motion. And again, the orientation depending on which way it's pointing. So on this one, you can see the little servo horn is pointing that way, whereas if I rotate this one round, the other one is pointing, if I just show you there, is pointing the opposite way. So both of these are pointing in opposite directions, and one of them is inverted. And they're on channels 1, 7, 3 and 5. Again, you can choose whichever ones you like, and you can make these configurable in your code, but just be mindful, if it starts doing really odd things when you're trying to do the walking cycle, it's probably because you've got the channels mixed up. So that's the configuring the feet. So what we need to be able to do with our MakeCode is produce some statements, some commands. So we want to be able to walk the robot forward, walk it backwards, turn left, turn right, make it stand up, which means putting all the feet down, making it sit down, which means making all the feet come back up, so its belly's on the floor, and maybe doing something else, like setting all the limbs to a default position, that kind of X shape, the dead cat orientation. So positioning the limbs, I came up with some terminology to sort of help. Let's get a bit closer to the microphone. Some terminology to help in the code explain to myself as I was writing it what this is all about. So I've come up with this idea that there's a body, which is kind of all the limbs forward and the feet sort of straight down. The stretch position, the stretch is forward, body is when they're out like a T shape, default is that kind of X one, and there's either feet up or feet down as well. So we need to create some commands for each of those, and it'll make the walking sequence a lot easier than rather than trying to define angles for each servo. It just makes more sense. So the body position is when they're all together, like so. They kind of form a horizontal line. The stretch is where they're straight up, and the default or the swing position is this kind of X position, which I'm trying to model on the screen at the moment, like so. Okay. So the walking cycle itself, so there's actually 12 sub-steps, or 4 major steps with 3 sub-steps in each for the walking cycle. So what we can do here is we can say for step 1, we need to set everything to the default position apart from the front right foot. I'm just looking at, I think I've got that. This is an old slide actually, and I've actually corrected it. Can you see there it says front, back, back. Front, back, back. And that should say front, back. I've corrected that in my later slides. But what we can see there is the very first thing is we need to move the front right foot, which is this one here, front right foot. That needs to go up. Then we need to swing round the front left and front right legs. So that's both of these legs. Swing them both round, and then we need to put the front right foot down. So it's going to lift up and it's going to go down. The reason that we move the other one but without lifting it up is because we actually want that to move the body forward. So by moving it and not lifting it off the ground, that's how we get that sort of motion. So it's kind of like a swimming motion. We want to sort of get it to do that and do that. So that's what we need to do. And step 2 is similar. We need to put the front left leg into the stretch position, so that's going to move like so. It's going to lift up first and then go down. That's what that command there does. And you can see just all these things in grey there. That means we've not touched that limb or done anything to it, but that's the previous state. So this is actually a state model that we're creating here. And then you can see there it's going to go to step 3, which lifts the back left leg up, swings it to the body position and puts it down. And then finally, the back left foot will go to the body position, then it will stretch, sorry, it'll go up, body position, stretch, and then down, like so. So if you want to get a copy of the updated diagram, I've actually put this into a PDF document for you to be able to download. Should have printed this off so I could show you this on the camera. You can get a copy of that from buymeacoffee.com/Kevin McAleer, and the details there. There's a link as well down in the video description on YouTube if you wanted to grab that. It's £4 to buy that PDF, and that helps support the channel. Or if you're a member of the Buy Me a Coffee, my membership thing, it's only £2. So there'll always be discounted pricing for members. But I've put in there 3 things. There is this walking diagram, and there is the microbit pinouts that you saw earlier, and there's also a microbit poster. So I've got my posters up on my wall over here. I don't know if you can see them in the big shot there. So I've got a microbit one, a pico one, a 0 one, and it's going to have a microbit one just there as well, just after I printed that out. Okay, so MakeCode. You might not have seen MakeCode before. It's a pretty cool environment, I've got to say. So obviously designed for education. You can see a little simulator on the left-hand side there, and it's very similar to Sketch. What's the name of it? Not Sketch. What's it called? Help me out here, people. The name of the thing that you Scratch, that's what I'm thinking of. It's very similar to Scratch or Google Blockly. So you have these little blocks, you can drag them onto this canvas, and then you can add them together to create a program. So it's very simple, designed for education and for sort of people beginning in programming. But the cool thing is you can switch between the block mode or Python or JavaScript. So it will render the code out depending which blocks you put there, and vice versa as well. So yeah, Scratch or Tinkercad. Tinkercad is very similar to this as well. So this is a great environment for learning what you can do with the microbit, putting your sketches together and putting your code together. And I found this really simple to be able to get the robot to walk. So we just needed to create some variables first. So this is what we're going to do. Put on there blocks or Python, because why would you use JavaScript for this? It's a horrible language. So we need to add an extension. This gets around at the very beginning. I was talking about my painful journey, wasting half a week trying to figure out how to get I2C working. Somebody's already done this, of course. So all we need to do, and I'll show you this in a second, we go to MakeCode extension, we click on the advanced and the extensions, we then type in this github.com/waveshare/pxt-servo into our search bar, press enter, we click on the little tile, and then that's added to our code, and we get this new servo block. That's the magic. That's how we can bring in our servos. And all we need to do is just say the servo is going to be 90 degrees and it'll just move the limb. So we can have a play with that in a second. So just to show you how this works, you click on the extensions, you go into the search bar, type in that wave share pxt-servo, and then a little tile will appear after you've clicked the little magnifying glass. You click on that and it adds it to your code. Nice and simple. And this is what you get. You get these little green servo channel things. You can either set the pulse width modulation. Why would you do that? Or you can just set the degree to what you want it to be between channel 0, 90 degrees. And the channels, remember, correspond to the limbs. But we can use variables instead of using horrible numbers. We can just say left leg, front left leg, front right leg, that kind of thing. Set it to 90 degrees. So much easier. So one of the reasons I wasted so much time on this, so it turns out microbit.org are a little bit inconsistent with their use of Python. So MakeCode and python.microbit.org, very different versions of Python on there. So they don't use a consistent library. The microbit itself doesn't seem to follow the MicroPython machine philosophy, where you have this machine that contains all the nuances and everything that's specific to that system board. Which is what we do with MicroPython. No, they don't do that. They have a it says microbit there. Just looking at the code there. It has a microbit library that you bring in, and that has some of the functionality. And even then, they're not even consistent with that. So this doesn't help writing code run everywhere. And I wasted quite a bit of time getting people's code off the internet, fiddling about with it, and then it doesn't work at all. So for example, if you want to put a little image on top of the microbit, using the LEDs, there's different ways of doing that depending on whether you're using the python.microbit.org or whether you're using MakeCode. Why would they do this? I don't know. So I found that the hard way. You don't need to do that. You can just go straight to MakeCode and not worry about any of this. So I've actually created some code that you can download if you want to play with this. You can just go to github.com/kevinmcaleer/microquad, and you can download this. And Adam says, isn't MakeCode based on CircuitPython? I'm not sure, actually. Because they don't use the machine, and you should use the machine as part of MicroPython. Not sure. But you can go to this link, and I think you can actually bring that as an extension, and it brings all the code in and everything. So it's a nice way of getting up and running very quickly with that. So shall we have a demo? Shall we have a play with this and see what we think? So let me just bring up a browser that's got it ready to load, and we can rock from there. So yeah, that's all good. So like I said, if I plug in the microbit itself, you might hear it buzz as the servos come to life. I'm just going to unplug that camera and plug that in there. Running out of ports there. So if you hear kind of a grinding sound, that's the and a little hello sound from the microbit. That's what's going on there. So if I just go to that view for a second, You can see there's a little flickering light there, and if I press one of these buttons, I think it's the left one, it'll just get one of the limbs to move. That's my little test piece of code there. And I also use this middle one here, the touch thing. This is microbit version 2. That's an extra button as well. So that's what I'm going to do. I'm going to go back to the main code page. There we go. Oops. Let me just load that like so. Like that. Why can we not see that properly? You don't need to see all that in the background. Do I need to click on it? Oh, if I go back to that view there, that's fine. That's fine. Okay, so what we've got going on here then, let me just see if I can connect to it. I think I just have to, let me just refresh the page. There we go. That little hello is the microbit saying that it's awake. And what we can do, we can start to play about with. So I've created some code already for you here, you can see. So this on start block here, this is like in the Arduino where you have the setup loop, or on a Pico where you have the boot.py. That's the piece of code that runs first. So what I've done here is I've created a number of variables. If I click on this little variables button, we can see that I've created left foot, left back foot, and let me just go back to there for a second. Left back foot, left back leg, left front foot. I can't even pronounce these things. Left front leg, right back foot, and so on. So we've got all 8 limbs basically there. And then underneath there we have this set or a change block as well. So if we want to, if we just actually create, I'm thinking, is it best we start from scratch on this, or should we just create another little piece of code to the side? Let's create some code to the side. So there is on here an advanced block. If I click on that, I can create a function. So we want to create a little function. Let's give it a name. So let's call this one stand up. Okay. And what I will do with my little stand up, I'm just going to move it over here. So we can on these ones, I think, just click on that little button there to hide them, like so. Okay, so we've got a little stand up thing. So what I want to do with my servos now is I'm going to grab set servo something to some angle. So I'm going to drop that in there. I'm then going to go to my variables and I'm going to look at the feet. So let's get the back left foot and let's drop that into, why have I done the wrong one there? Let's not use that one. Let's go back to, so I was using the wrong thing actually there. There we go, drop that in and then drop the variable into that little hole there, and then we can select as a drop down which one. So we want the feet, we want back left foot, and let's set that to 90 degrees to begin with. And there's even like a little slider there, so you can slide it about to the value that you want, or you can just type it in. So at the moment this isn't going to do anything. The robot itself, if I go to the overhead there, is just sat there. I think its feet are down, so I want them feet to sort of go back up like so. I'm just going to move this around so you can see it a bit better there. And what I need to do to download it into the microbit is just press this download button. It's then going to, oops, it thinks I've got errors in my program. Nonsense. There we go. There's a connect to your microbit. It says I'm connected. And do I just need to press play? Let me have a look what's going on there. I might just connect and disconnect for a second. Let's just disconnect it. And then reconnect it. Okay, and then let's go back to the window there, and then let's try again. It shouldn't be downloading it into my browser, it should actually just be downloading it to the robot itself. So I'm just going to disconnect. And let's try reconnecting it. What's it saying there? So you need to click on the padlock. Ah, right. Okay, let's just reload that, and then it's going to try and connect it again. Pair device, allow, click connect. Okay. Oh, why is it saying there's a problem with my code? There's no problem with my code. Let's start from scratch, shall we? Let's do a new program, new project. Let's go back to the full screen. Let's create a new project. Let's call this one new quad. Okay. Let's just move this back up there. Like so. Okay. So at this point we haven't got that servo thing loaded. So we click on advanced. Let's get rid of that there. We then click on extensions. And then in the URL we are going to type in that address. So it was https github.com/wave share, I think. This is just from memory then, was it pxt-servos? Something like that. Let me just find the exact thing from the slide. So let's just find that. Grab that. And then we're away. So let me just grab that open link. Okay, let's go back to here, just paste that in. Oops, I've got a little comma there at the end. There we go. So you click on the tile, that's now loaded in this servos thing there. And what we can then do is drag these out. So I want to drag out the one, not the pulse width one, I want to drag out the other one, which is that one. And I'm just going to do that in the forever area for now. Let's go back and create another function again. So function, make a function, and let's call this one stand up. Okay, just so that we can go into there. And we can create a little loop in the forever one. So we can say while true, that's usually what people do with Python. And then we can grab the name of that function that we just created, which is called stand up. Like so, and it'll run this little function forever. Now before we do that we need some variables, so what we need to do is create a variable, and let's call this one front left leg, like so. And what I'm going to do is I'm going to drag that into this little area here, so whatever value is stored in front left leg, it's going to put into there. So back on that variables thing, we need to set what that value is, and that's going to be the channel. So I'm just going to hazard a guess that I've set the very front, very first variable to be channel 0, and I don't actually think it's front left leg, I think it's front left foot. So let's just make another one, front left foot, like so. And then let's drag that one out to there instead. I could have just used the drop down actually. Front left foot, that's fine. And then what we'll do on here is just change that one to be front left foot to be 0. And what we'll do, we'll get it to do 90, then we'll get it to pause asleep. So I think that's in basic, is it? I think there's a pause, there it is. We'll just drag that one out. Let's put that one underneath there. And then if I click on that one, I can actually do Control-C, Control-V to paste it, I believe. There we go. I can put that underneath and then set that to 0. Oh, did we say 9? Was it 9? 90 to 9. We don't want it to break. And then let's have another pause. So let's click on that, copy and paste, and then let's drag that back up underneath it. Okay, should we try loading this now? Let's see what happens. Yep, if I could. We're doing 100 milliseconds here, so that's what it's currently doing. So I think we need to change that to be 1 second. What say you? Let's go to 1 second. And then we click on download again. Okay. Now that's not the foot, is it? That's not the front left foot. I think that is the front left leg. So let's just... We also need to create a thing that says stop. Otherwise it'll keep running. I think if we click on that stop, does it stop? No, that just stops the simulator. Right, so what I'm going to do is I'm going to create another little function very quickly. Let's just go back to the full screen view of that for a second. I'm going to create another function that's just called stop, so we can just say stop. Let's just create a new function. We'll call that one stop. And what we'll do in stop, let's just hide that a second. We will drag in that servo. Is it a servo? Yeah, let's drag a servo in. Let's drag in that variable which is called front left foot. Let's have another one of those. And what we will do is just make them set to 90 degrees. So let's make both of them 90 degrees. Okay, and then all we then need to do is, instead of doing while true, we can just drag in the new function that we've created. So to function, call stop, and just drag that up there and then flash it, and it should just stop it and then run it forever. No, that's not right, is it? If we just drag that out for a second, like so, you can see it's greyed out there, and then flash that, it'll just stop. There we go, perfect. Right, so some of this code isn't quite right, is it? Because it's like the front left foot isn't 0, that's actually the front left leg. So in our start one, we can set that variable to begin with, but we need to figure out which one it is. So I think it's probably going to be number 1. So if I go under there and set the next variable to be front left foot and change that to 1, channel number 1, and let's see if that now works. So I've not had to change any of my code, I'm just changing the channel numbers up here in our setup, in our start bit, to see does that actually work. So I'm just going to drag that up here, and then I'm going to flash it again, and let's see what happens now. So that's the foot. The foot is just going ever so slightly. If I just lift this up, you can see what's going on there. So I think that can go higher. I think that 90 degrees, I think it needs to go higher than that. So let's have a look in our code. So our stand-up code, we want that to go to, so the 9 is the one that's going down. Let's make that go to 150 instead. Like so, and then let's just download the code. It should actually lift up now rather than, there we go. So it's going from the default position at 90 degrees, which is kind of like so, and then it's going up. So that's perfect. Okay, so we need to do that with all 4 feet, and we just need to run that other piece of code to get it to stop. Because that's a bit irritating while you're trying to code that it's running that. So let's just click on that. Okay, so what we need to do now is we need to create some more variables for our other feet, and we need to figure out which channels they're actually on. We could just come and look at the back of it and follow the wire around, or we could just do what I do and just hack it until it works. So I'm just going to create another little 2 of these, and then we're going to create 2 more variables for the other feet. So we need one which is front right foot. We need one that's called back right foot, and we need a back left foot as well. Back left foot. Okay, so now we can select these from the drop down. So I'm just going to guess these are just 2 and 3. We had that sheet before that I could have printed out and referred to that, but let's just set this to be back left foot and back right foot. And what I'm going to do in my stand-up code, which is just here, oops, let's just make that stop one hidden for a second. So where I've got front left foot up and down, I'm going to make all of them go to 150. So let's do 150. Let's make that the back left foot. Let's get rid of that pause because we don't need that there. And then let's just copy that twice, like so. Let's just move that pause to the end. And that needs to be, so we can have front. Let's have that as back left. Let's have that one as back right. Let's have that one as front right foot. Okay. So I don't think this is going to work because I think them numbers are all wrong. I know 0 is correct. I don't know about 1, 2 and 3. Let's see what happens. We might break our SMARS Quad robot, but let's see what happens, shall we? So I'm going to go over here. I'm going to click on the download button and let's see what happens. Oh, and of course in our code we need to get it to run stand up. So let's just do that again. Yep, you can see that. What is going on? So that's not right. So what we need to do is change one of these to be 4. Let's see what happens then and download it. Remember what I was saying about inverting them? You said that's 4 is one of the legs, so it's not 4. Let's change that to 5. Download it. Now 5 looked correct. I think 5 has actually put one of the back left leg, so is that correct? So back left leg is 5. Sorry, back left foot is 5. Let's try 6 for that one. Nope, that's the front right leg. So front right leg is 6. Let's try 7 in that case. Seven is front right foot. Front right foot is 7. So let's go to, let's try and get that drop down there to be what I'm after. Let me just go back to that. Oops. Live coding. So on start, front right foot, it should be 7. Front right foot is 7. Right, let's try that again. So let me go to, I always create another function, well, the stop one works fine actually, where we just set everything to 90 degrees. So let's just drag in, let's just copy those every single limb actually. So let's do front left, front right, back left, back right. And then let's just go back up here and pull out that loop for a second and then just download it. Like so. Okay. Manually put them into position. So what your homework will be is to continue this on. So what I looked at when I was putting the code together there, on this start block, which is this block here. Let me just bring that to full screen there. So this start block here, the left leg, the left right foot, that should be a foot, shouldn't it? I set all the feet, then I set all the legs. I figured out which channel was for each. And then you only have to do that once in your startup block. So you've configured each channel to each particular limb. And then you create a function for each of the commands that you want to do. So a stand-up command, you would figure out what the correct left foot, right foot, and then what are the degrees for them. Now some of them will be 150 and other ones will be the inverse of that. They might be 55, something like that. So you'll have to see which of them is correct. I always put a pause at the end and that gives enough time for the servo to physically move into place. If you don't have the delay there and you have lots of these happening at once, you might not see any action at all, and that's because the servo needs physical time to move, and your computer can run at, what is it, like 150 megahertz or something, so it's really quick and it will do all those things very, very quickly without giving enough time for the servo to move. So I'd create a stand up, I would create a sit down, I would create, and the walk forward, you essentially need 12 subcommands. So I'd create 12 functions, and what they would do is they would set each of the 3 things that move, and then you can call them in the correct order then. So you can then say, you know, step 1 step 2, step 3, and so on. And you'll see the robot start to move around. And if you want to do backwards, it's the reverse order. And if you want it to turn left or turn right, again, you just need to think about how that will work. So do you just need to put all the limbs into the sort of star formation, that X formation? Oops, whacked my camera there. Into the X sort of thing, and then you want the body to sort of twist. So what does it mean to twist? Well, I'm moving my left leg to the body position, and I'm using my right thing to the stretch position, but I've not lifted them up, I've just moved them. And that will give you that twist, and then you need to sort of lift them up and do the twist again. So think about how you physically move around, and you'll get there with it. So let me just see if there's anything else I needed to cover off there. I don't think so. And hopefully this was enough of a demo that you can actually get to where you need to go with this. So Android lover, this was for you, this video. I know that you hounded me on on all the social media to say, yeah, but you just need to do a microbit with MakeCode on the SMARS robot. You need to do it quite quick. So hopefully I've delivered for you on that one. But it was a load of fun to do that. Now the other cool thing, let me just go back to the MakeCode for a second. You can't, you can do walking, but you can do so much more with this. So in the microbit library, you've got all these other things like music. You can make it play a melody. You can make it do different sounds. So one of the things I thought was really fun to do, and like music, let me just show you some of the music that it can actually play, because it has some built-in pieces of music. So let's drag this one into, let's just do it in our startup one. Right, and let's have a look. One of them somewhere has like Nyan Cat, I kid you not. So let's just get it to do mystery, whatever mystery is. So if I go down here and download that, let's see what happens. So have I got that plugged in? Yes, I have. Why can't I hear it playing? I'll go on startup. Let's try that again. Let's do that again so you can hear it. I'll hold it up to the microphone. So that's one. And then there is, as well as music, I think at the very bottom of music, there is sounds. So this is a microbit version 2. So if I drag this one over, let's get rid of the melody. Oops. How do we do this? If I just click on that, delete, yeah, there we go. So it's got like hello, happy, it's got mysterious, sad. So I like that hello one because it kind of goes rare. Like that. I don't know if you can hear that. You've got giggle. So you can make it do different sounds depending on what command you want to do, or give it a bit of expression. And then you've got the LED lights as well, so you can go over to LEDs. Actually in the basic one, I think, there we go, show LEDs or show icon. So you can actually design your own. You can do a little face, kind of like that, just by drawing it out. So if I do that and then I just flash that, and I just show you on the overhead, it's got that little, it looks like it's flickering. It's not, it's just the camera. I don't know if you can see on, no, you can't even see on there. But yeah, it's got a little face on there. So there's so many cool things you can do with this. Honestly, that's probably where I really wasted half the week, was just messing about with this. And you can do other things as well. So as well as doing like, you can put text across the screen, so you can get it to say hello. So if we do that, it will scroll across the screen. So if I do that, you can probably just about see it there, saying hello, like that. And what else can we do? You've got all the different sensors in there as well. So as well as those basic things, and you can do arrows as well. You can make it look like a forward arrow, backwards, that kind of thing. You've got buttons as well, so you can drag in a button. So if we have in our little forever thing, we'd have to have a loop of some kind. But you can actually test to see if button A has been pressed or not, or button A and B, and so on. And then if you press that, it will do a particular action. You press another one, it'll do another action. So maybe you have different programs. You could have like an avoid or a follow, that kind of thing, depending which button is being pressed. You can even plot graphs on this thing. If you've got more than one microbit, you can get them to talk together using the radio function. What else have we got on here? There is some more stuff, I think, down here. Let's see if I can find it. What is the one I was thinking of? The accelerometer stuff, that was it. So I think that's possibly in game, is it? But yeah, you can actually see which orientation your robot is pointing in, which is just ridiculous because you know, you have to do quite a lot to bring that into a SMARS robot normally, but we can actually use this to see, has it turned 90 degrees, because it's got a compass built in. How cool is that? So is it under control? I can't remember where this is actually. So the other thing I've not shown you on here, just before we go, so that's blocks. Now you can just click on Python, and all that stuff you've just written using blocks is available to you. Look, there's even like the basic show LED. That's how you do it as a Python piece of code. Or if you want to do it as JavaScript, I don't know why you would. You can do that there. You can just click on it, or you can go back to the Python view. If I go down to the bottom of this Python thing here and I just do a def hello world like so, I create some code and I do, let's have a look. Let's do that. Actually, let's just do show string. Let's just grab that piece of code there, and I can paste that underneath. And let's get my indentation correct. And then instead of saying hello, if I just go hello world, if I now go back to blocks, it will have created that function. If I can find it, called hello world. There it is. And I created that using code. So, and I can even see what does that look like in JavaScript. So it's quite cool how it does backwards and forwards. The other cool thing is you've still got these blocks available here. So if you think, how do I play a piece of music but in Python? I click on that and I can just drag that block there into my code and it types the thing out. So you can even do drag and drop coding in Python in MakeCode. So this is really, really cool. So I would encourage you to go and have a play with this. Even if you've not got microbit, you can just play in the MakeCode environment there. You can then even synchronize this with GitHub. So you can say, here's a new quad. You can give it a description. You can say, go ahead. I've already logged into this MakeCode, so it knows what my GitHub repository is, and it will upload it to GitHub. So you can share this with other people. You can go back to stuff you've created previously. And yeah, it's pretty clever. And it obviously has all the version control as well. Look at that. Really cool. And I just love the sounds that it makes. Okay, so hopefully you found that really useful. If you want to know more about robots and stuff, I do go live every single Sunday. What is it doing? Every single Sunday at 7 o'clock-ish GMT. So that might be British Summer Time is like 1 hour minus, isn't it? So it might be 6 PM your local time. They're the different time zones. We have all the Americas and Canada on the left. We have India, Pakistan, Europe, and a bit of Russia in the middle column. And then on the right-hand column, we have China, Australia, New Zealand, that kind of area. So that's the videos. And then there is the SMARS Fan website. So if you go to smarsfan.com, you'll find loads of information about SMARS robots, how to build a quad robot, all the different components you need, some sample code for Arduino or Python, all the links to the videos and so on. That's all there. So check that out. And if you want to help out the show as well, oops, we've already done that one. If you want to help out the show, you can always go to buymeacoffee.com/Kevin McAleer and just buy me a coffee, and that can help run the show for a little bit longer. Pays for all this expensive gear that we have, all the graphics software that I use, all the streaming stuff I use as well. Yes, you get the picture. Takes quite a bit to put one of these shows together, but hopefully you found that really cool and useful. I loved having to play with this. I'm going to do more with these microbits as well. We could probably do the same thing, but with a regular SMARS robot as well. Wouldn't be too difficult to do that. So hopefully you enjoyed this, and I shall see you on Sunday for part 2 of the Build Your Own AI. Hopefully you enjoy this. Let me know in the comments. And let me just very quickly, I'm here wrapping it up, and there's some questions from people. So Android Lover said, yep, amazing, really appreciated that. And Adam says, I'm fighting to understand the programming of another quad, so thank you. No problem. And how long can you nine? I can nine for a long time. Kymate Richard said, awesome, need to get back to work. And Adam was saying about machine CPU uses different layout to the core. Yeah, the Circuit Python is a bit different. I don't like it myself, but this is just my personal preference. I think I'm more of a purist. I like pure Python and pure MicroPython. Adafruit have done what's best for them and their products, because they've got all these different products that they want to sort of put together and make it look like there's one ecosystem, and they've built Circuit Python around that, but it is kind of a spur off regular Python, and only they do that. So I'm not sure why they took the decision to do that. Anyway, thank you all for watching. It's been a good stream, this one, I think, so far. Again, no number of people I think who've watched this one, so thank you for being with me today. It means a lot, and I shall see you on Sunday. See you later.